Hello, this is section 2.1 organizing data. So objectives for this section is learn how to construct a categorical frequency distribution. So frequency distribution. A frequency distribution is organization of the raw data of the table in the table form using classes and frequencies. So categorical frequency distribution. Frequency distribution is used for data that can be placed in a specific categories, such as a nominal or ordinal level data. For example, data such as a political affiliation, religious affiliation, or major field of study would use a categorical frequency distribution. Constructing a categorical frequency distribution. So step 1, we're going to make a table as a setting as class, tally, frequency, and percent. And then step 2, we're going to tally the data. And then step 3, record the frequencies from the tally. And then step 4, we're going to calculate and then recording the percentage. So, example. A researcher played the mobile device game for 2 hours. The objective of the game is to capture as many virtual characters as possible. The following table shows the list of the characters captured after 2 hours of play. So there's a plastic, insect, wheat, metal, and then there's the liquid. Okay, so there are 5 different kind of characters. Okay, so in the classes, since there's a name of the character, so I'm gonna put it as plastic, insect, wheat, metal, and liquid. And then I'm gonna use the recording the data. Okay, so plastic right here 1, insect 1, wheat 1, metal, plastic, liquid, plastic, insect, wheat, insect, wheat, insect, and wheat, insect. So every bar I'm gonna put this way is a bar, plastic, insect, liquid, plastic, wheat, plastic, metal, wheat, insect, and insect, liquid, plastic, insect, liquid, plastic, insect, insect, liquid, insect, wheat, and plastic. So what I have in here is, okay, so I got 9 for plastic and insect, which is 12, and wheat 7, metal 2, and liquid 5. And then total must be, actually there is 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5. So we must have a 35 total. So if I'm adding it up together as a frequency total is 9 plus 12 plus 7 plus 2 plus 5. Alright, so which means I haven't missed any, okay? And then percentage always whatever frequency divided by the total. So frequency divided by total, and then multiplied by 100, that will be the percentage. So which is rounded up to the whole percentage, so 26%. 12 divided by 35 times 100, which is, I have 34%. And 7 divided by 35 times 100, I got 20%. And then 2 divided by 35 multiplied by 100, I got 6%. And 5 divided by 35 multiplied by 100, I got 14%, about 14%, okay? So about the total percentage should be 100 too, okay? All right, so that's how you're making a table form. All right, now group the frequency distribution. So when the range of the data is a large, data must be grouped into classes that are more than 1 unit in width in what is called the group frequency distribution. Attributes of the appropriate drawn group frequency distribution. So usually the classes we want to make up between 5 and 20. And then it is a preferable but not absolutely necessary that the class width, we want to make that as an odd number. And then class must be the mutually exclusive, and class continuous, and then the class is exhaustive. Constructing a group frequency distribution. So step one, we're going to determine the classes. So find the highest, the lowest value from the data, and then we're going to find the range. So range means you're subtracting from highest value to the lowest value. And then you got the range. Select the number of the classes desired. So this is your choice from the between 5 and 20. Find the width by dividing the range by the numbers of the classes and rounding up always. Select the starting point, usually the lowest value or any convenient number less than the lowest value, and then add the width to get the lower limit. And then we also want to find the upper limit and then the boundaries. So at then step 2, we tally the data from the data set. And then step 3, find the numerical frequencies from the tallies and then find the cumulative frequencies. Okay, we're going to use the this example on here. So there are the table that contain the numbers of the members of the United States Electoral College allocated to each state as the 2016 U.S. presidential election. So as you notice here, so state Alabama has 9 votes, Alaska has 3, Arizona has 11, California has 55. I think that's the most number of the votes that gets from the state, right? So what is the electoral college? The number of the members of the electoral college for each state is equal to the state number of the members of the Congress. So District of the Columbia also has 3 members. So most states have the winner takes all system that awards all electoral votes to the candidates who win the popular votes. Well, however, Maine and Nebraska employ the proportional representation system. So not every state has that, okay? So on the next table, okay, I already sorted by the number of the votes, okay? So starting with the 3. So there are the 1, 2, 3, 4, 5, 6, 7, 8 states got 3 votes. 1, 2, 3, 4, 5. 5 states got 4 votes, and then 1, 2, 3. 3 states got 5 votes. So I had to put it on here together. All right, so let's get to the class width. So the guideline suggests the class width to be odd number, but that was not absolutely necessary. So we will go ahead and use this class width as 8. So your decision. So I'm gonna make the class width as 8. Even though it is not an odd number, we can still define this. So let's see how we can get the 8 here. So first of all, we're going to get the minimum and maximum to find it. So maximum votes are 55 and minimum votes are the 3. So we subtract them each other to get a range, which is a 52 is a range. And then we decide to make the 7 classes. That's your choice. You can choose from the 5 to 20. And then, which means whatever the range divided by 7 classes, and then you get the 7.43. And for the class width, we always round it up. So instead of 7, we'll say 8. So find the lowest class limit. First, select the starting point. So we're going to start from the 3 because 3 is the lowest value. You can use that. It can be the smallest value of any convex number less than that. The starting point will be the lowest limit from the first class. So lowest limit, I start with the 3. And then I'm using the class width is 8, which is I'm adding the 8 to 3 to get 11. Adding 8 to get 19. So you keep adding the 8 to get the next number. It's 27, 8, 8, and 8. Okay. So that's where you use a class width. The class width means you're subtracting the 2 consecutive low limits, and then you get the class width. So like 11 minus 3, 19 minus 11, 27 minus 19, 35 minus 27, 43 minus 35, 51 minus 43. You all get the 3 as a class width. And then, in order to get the upper limit, okay? And this is what you do. So you have to take a look at the next class 11, lower limit 11, and then you always subtract 1 from that lower limit, which is 10. So 3 to 10, which is there's a 19, so 18, 27, 26, 35, 34, 43, 42, 51, 50, and then upper limit also has a class with an 8 because 10 plus 8 is 18, 18 plus 20, 18 plus 8 is 26, 26 plus 8 is 34, see? So you got to adding 8, so you got 58. And then that's what you have the classes, okay? Class limit. So you got 1 class, 2, 3, 4, 5, 6, 7 classes, okay? So if I summarize it, limit gonna be 3 to 10, 11 to 18, 27 to 34. Oh, sorry, I skipped the one, the class. 19 to 26, and 27 to 34, 35 to 42, 43 to 50, and then 51 to 58. So those are the limits, okay? Then we already found the class limit, the upper class limit. All right, so we are using those to make the limits and boundary table. So limit is we already have as 310, 11 to 18, 19 to 26, 27 to 34, 35 to 42, and 43 to 50, and then 51 to 58. And then for the boundaries, since we're gonna get the boundary from the lower limit and upper limit, so if I'm using the first class, so what I do is, boundary is the same thing. So adding the 0 after decimal point, adding the 0 after 3, and then for the upper class limit, you adding the 0.5, so which is 10.5 as an upper boundary, and then for the lower boundary, you're subtracting 0.5, which you got 2.5. So boundary should be 2.5 to 10.5. So now next class starts at 11, so 11 minus 0.5, same as 10.5. And for the 18, you're adding the 0.5, so 18.5. Also, the lower limit is repeated from the upper limit from the previous class. And then you got the 26.5, 26.5 to up to 34.5, and then 34.5 up to 42.5, 42.5 up to 50.5, and then 50.5 up to 58.5. And then I'm using the table, which is this table, to get the tallies, okay? So when I looking for the number between the 3 to 10, let me see how many are there, okay? So 3 to 10 means there's a there's a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. So there are 34, okay? So which is tally means 1, 2, 3, 4, 5, 1, 2, 3, 4, 10, 1, 2, 3, 4, 15, 1, 2, 3, 4, 20, 1, 2, 3, 4, 5, 25, 1, 2, 3, 4, 30, 1, 2, 3, 4. So there are 34. And then between the 11 and 18 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's a 11, which is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, so 11. And then between the 18 and 26, which is 1, 2, so there's a 2. And then the 27 to 34, which is 1, 2. So 1, 2 for 2. And then 35 to 42, there's a 1. And then 43 between 50 is none, which is a 0. And then 51 to 58, there's a 55, which is 1. So there's a 1, okay? So this is how you fill out the group frequency distribution, okay? And then we also gonna find the midpoint from the each classes, because first class is between the 3 and 10. So we're looking for a middle number between the 3 and 10, okay? So which means in order to get a midpoint, there's 2 ways. One is using the boundaries, which means the lower boundary and the upper boundary, right? Add it up and divide by 2. Or lower limit 3 and 10 together and divide by 2. So either way, you're gonna get the same thing, okay? So let's say xm for the midpoint. And then how do you do? 3 plus 10, which is 13 divided by 2. I got 6.5. So 12, right? And then 11 plus 18. And then divide by 2, I have a 14.5. So as you noticed, also the class width apply that too. So 6.5 plus 8 is 14.5. And then 14 plus 5 plus 8 is 22.5. And 22.5 plus 8 is 30.5. And plus 8 is 38.5. Plus 8 is 46.5. And plus 8 is 54.5. Okay, so those are the midpoint. We are not using in here, but we'll using later. And then cumulative frequency distribution or cumulative frequency distribution that shows the number of the data value less than or equal to the specific value, usually the upper boundary. The values are found adding the frequencies of the class less than or equal to the upper class boundary of the specific class. So less than 2.5. So what I do is we're using the upper boundary, which is this numbers. Okay, and then I can put the 2.5 as in the 0 class, which is first, second, third, and up to 7th. But there's a 0 class boundary is upper class boundary is the 2.5. So less than 2.5 means nothing. So we always try to starting with a 0 because that actually make the graph right on the x-axis. And then 10.5, which is up to here, which is 0 at 34. And then up to 18.5, you gotta add it up for 34 to 11 as a 45. And then up to here, so adding to 47. Up to here, 49. Up to here, 50. And then up to here, nothing changed, 50. And then up to here, it's gonna be 51. So that's what we call the cumulative frequency, okay? So last number that you found is always same number as the data value. Alrighty, thank you for listening.